All right, so yeah, so we're going into, was it section 15? Remember section 16, if you guys have reached that point yet, it's mostly web scraping. It's going to be lessons, so I'm not going to have a specific study group for that, right? So this is technically the stuff that we would have done yesterday, but we're doing it today. Give you guys some extra time. So just quick thumbs up. This is section 15, MongoDB, NoSQL. Who was able to get MongoDB installed and be able to run? Okay, cool. So Lauren, I know you had some questions before, Lauren, right?
Yeah, so I feel like it was installed in my terminal, but when I imported it to Jupyter, it was coming up with all sorts of errors. So I went through the lesson plan, but I'm having trouble with it. Jupyter.
Okay,
I can talk to you during my one-on-one.
sounds perfect. Yeah, sometimes those things can get a little tricky, so we'll go over that. But I'm glad the rest of you guys had installed. So anyway, let me go ahead and start sharing. I'm going to share my whole screen this time. Oh, excuse me. Had a little hiccup. Desktop one. Cool. All right, see, I don't know what Zoom does. Whenever I share my screen, I put you guys on a different window and it was fine. And then it's Zoom's like, oh no, I need to reshape this window for no reason. Whatever. Okay, so let me move this out so I can actually see. Okay, cool. So always, I have the resources now on that repo. So on the Flatiron repo, or yeah, the repo I have, it's under data engineering. It's under NoSQL. Note, I realized no one said anything for a while. It must have been at least 2 months. It turned out when I talked about MongoDB, or I think it was the NoSQL part, it was the wrong notebook. I overwrote it by accident from one previous lesson, so no one ever said anything. So glad I found that. But anyway, it should be good now. So if you go to that repo, you find it fine. So let's talk about NoSQL in general, right? So I'll just make it big since I have this full desktop screen. All right, so NoSQL. So we talked about SQL itself, right? And so I kind of mentioned before, SQL is kind of considered a little old hat kind of stuff, but it's still I'm going to emphasize, even though it's definitely more seasoned and more experienced and has a lot more experience, it is still a very useful thing. Don't think oh, it's old, so I shouldn't use it, or it's not important. It's a very important part, but there have been some advancements. So one of them is called NoSQL, which is, I think, is hilarious, saying it's not SQL. It's not SQL. We'll talk about what it actually stands for. Oh, I guess right here, not only SQL, it's really what it stands for. But so the question is is SQL not good enough? It's well, SQL and NoSQL basically do different things. So SQL databases are relational databases. So they're really built for tabular data. When I say tabular, I really think table, right? So anything that you can put in a spreadsheet, that's usually what we think of SQL databases, but usually more structured. So it's really nice because it's very structured. It's very safe. It's very I think intuitive for most people who will work with other Excel documents. Anyone who's if you talk to anyone who uses databases who are not necessarily data scientists, data analysts, or programmers, they're relatively familiar and they can kind of navigate a spreadsheet or something that's relational database. So it's relatively nice, but it's also really restrictive. So when I say restrictive, what parts can you think of are restrictive for SQL? Yeah, so what do I mean when I say it's restrictive?
Oh, well, I remember from reading that it can only be with one server, right?
Good,
You can
right?
add multiple servers.
Yeah, that's right. You really only have one server. If you try to get if the data's in multiple places, it's a little harder to retrieve that information. There's some tricks you can do, but essentially you have to in order to do an aggregation, right? To say, oh, group by this thing. Well, you can't group it by on one server. You'd have to I mean, if you had multiple servers, you'd only be able to group it on that one server and then connect to the other server and then collect the information. But then that wouldn't be grouped by, so you have to group it by a different one. So you can imagine you have to really have it on one big server, right? So that's kind of a big issue. Another part of SQL really is you really just need to have your data really should have the same amount of columns. There really isn't a thing where you can say, well, this part should only have these columns and this one should only have these columns. You could kind of get away with this by putting none and stuff like that. But you can imagine let's say you have a few data items that have specific extra parts. You have to make a new table essentially to refer to those versus having it all together. So again, SQL is more focused on having table relationships over the data relationships. So in most cases, this is perfectly fine, and you can work around it, but it does make it more restrictive, but it also makes it more safe. You basically know all the relevant information for that data item should be on that one table if it's structured correctly. Okay. So this kind of goes into NoSQL, or not only SQL. I think at one point it was actually called like not SQL, or like NoSQL, like actually like literally NoSQL. But now we kind of say not only SQL because you can use SQL interfaces with a NoSQL database. So the main thing with NoSQL is that they're non-relational databases. Sometimes we call them distributed databases. Note that they're not necessarily interchangeable in that way, because distributed really just means that they're separated out, like Lauren had mentioned, like maybe multiple servers. And non-relational databases are just saying like they're not relating necessarily across different parts. So like think like when we have SQL, hey, sorry, she's being a little puppy and wants to be in my lap. Don't be too distracting. Okay, so our non-relational databases, like those are parts like you can have like really focus on the data itself. So I actually want to point to AWS has a great resource for like SQL versus NoSQL. This little link here. So I'm going to show you guys that. And again, reason why AWS has a whole bunch of information on this is because, thank you, I know you like SQL. So they have this stuff because they have a lot of data, right? And so you can kind of see like the equivalent, like here's SQL, like table, row, column, primary key, index, things that we've seen already, right? View, you can think of view as kind of like a subtable or a subquery. You want to go with that? Go down. She's so tired. Okay. And then you can see the equivalent like MongoDB, DynamoDB, Cassandra, Couchbase. These are all other NoSQL databases, and they all form a little bit different. Cassandra is one that I'm actually see a lot of, and you can actually see it's very similar to table, row, column, and it's structured a little bit different. But MongoDB, which we'll talk about today, we have collections. Each row is a document, so you can think of like each row essentially having its own separate kind of like structure. You see that it says field versus a column. You know, so they're kind of like how these relate to each other. There's also, in this case, a comparison of what SQL versus non-SQL databases, their advantages and stuff. So I'm not going to read this whole thing through, but you can kind of see there's different aspects in here, like how they go through. Excuse me. You can look at like performance. So what's really interesting is that performance is really dependent on like, for SQL relational databases, it's dependent on like the actual like disk, like what is running off of. But what's cool about like NoSQL databases, you can actually use like a cluster. And basically the big part is saying, well, if you have a cluster, like multiple servers, it talks about the network latency, basically how the servers talk to each other. So like if it takes a long time for them to talk to each other, that's going to determine your performance. So NoSQL isn't always good for everything. You can imagine that some cases it makes sense to have it more siloed off from each other and then connect to each other when they need to. But if you have to constantly use a network back and forth, back and forth, back and forth, that's going to be your slowest aspect of your like performance. So these are some interesting things that kind of go through. Again, it's on that link, so I definitely suggest reading this through. It's a nice little table. Okay. Cool. So like I mentioned, some advantages. You don't need to know the structure when you start, which is a huge deal when you first come across data. With SQL, a lot of ways you kind of have to already like have an idea of how the table is structured, or not table, but the database is structured. So you can have multiple tables. Remember, each table really should focus on essentially like a primary key, and then everything else should talk about that primary key. So if you don't know what the data is going to structure, right, you might have something that should have a primary key into like another table, but you don't know that ahead of time. So it can get really fuzzy in this way. This is something I'll refer to you guys like tidy data, TIDY data. It's kind of a philosophy. This is kind of like what SQL is trying to do, is like make tidy data. So it can be really difficult if you don't know ahead of time what the structure is going to be. It's also flexible, which kind of goes off of this. Basically, you're allowed to change things around. You don't have to update all these columns. You can basically update that specific document for that row. So you don't have to update everything at once. And then horizontally scalable. You'll hear this a lot, horizontally, meaning that you can basically just spin up new servers. So if you need more space or you need to do more things, you can start up a new server, essentially a new instance, and you don't have to like just expand your one server. So if you expanded one server, like basically, oh, I'm running out of space, like 100 gigabytes, like, oh, that's not enough. We need to put in like another terabyte in our drive, right, for that one server. That would be vertically scalable. So you can think of like SQL relational databases. Those use a vertical scalability. So you're basically increasing that one server's power so it can handle more. But you can imagine that's only going to do so well, right? horizontally scalable tends to be much more common now, especially for the web stuff, because there's a lot of advantages that you can do, which I won't go into, which again, I'll refer back to that little web page. Okay. Any questions on these advantages or how they're specific to NoSQL? Sound pretty good? Cool. Awesome. All right. So here's some examples. I'm not going to go through this part, but MongoDB, Google's Big Table, right? AWS's DynamoDB, which is referenced over there, Apache Cassandra. So most of these, for example, are just kind of like open for everyone to use. These are probably like, I would say Cassandra's pretty popular, though it kind of fluctuates depending on like what different services want to use, stuff like that. But usually, for example, if you use AWS or Microsoft Azure or Google Cloud Platform, they usually have some support of these different systems of like databases and stuff like that. So it's good to know, do you need to know all of these things and exactly how they work? I would say no. I say it depends on, you really should just know that they exist. Maybe a little bit of like, like some differences between the two. So if someone were to ask you like, should we use this one or this one? You might say, well, let me, I know these parts, but I can do some research. And then really what it comes down to is like whatever, company you're working with or whatever organization you're working with, whatever they're using is probably what you should stick with, right? So you don't have to like migrate everyone over. Okay, so those are some overall advantages, examples, and stuff like that. I'm just gonna split this up because that bothers me. There we go. Cool. So how do we actually how do we actually do this stuff, right? So the first thing to kind of know is that like we have different ways of doing NoSQL. So NoSQL is basically like, if you imagine there's SQL databases, which are relational databases, and then everything else is essentially NoSQL. So there's a lot of ways we can refer to NoSQL. So the one that we'll talk about today is like MongoDB, which is like data document stores. So essentially here is that data is structured as is stored as documents. So you saw in that like list of like MongoDB versus SQL, you can think of like each row, each data row is a document. And basically what's nice about this is that it's semi-structured, it's hierarchical. So you can say like, okay, well, these documents go first, or this is connected this way. But the big part is that it's semi-structured. So there's still structure within the document, but the documents don't all have to match with each other, which makes it really flexible, especially if you are like a startup or something like that, or someone who's just getting data for the first time and like, oh, we don't know what this is going to look like in the future. So it makes it a little bit easier for us to handle. Okay. So the next one is a key value store. So this one's kind of an interesting one, is that data is partitioned, and partition just basically is split up if you haven't heard that word before. And then we basically use a hash table to reference these parts. So what a hash is, is anyone familiar what a hash, when we say what a hash means? I see some kind of questionable looks. Okay, so you'll hear this quite a bit, right? So a hash, essentially what it is essentially you take some information. It could be like a string. For example, we talked about like hashing your password. You basically take some information and you put it through a special function called a hash. And this hash could be like a different kind of function, some funniness and stuff like that. And the idea is that it basically will take everything. If you put the same input in, no matter what the input, like if you put apples, it will always give you the same output. The output might look like complete nonsense to you, but it will always give you the same output. And the idea is that you can always put that in, and it's relatively fast to do that. I'll put a caveat, not true. It's not always fast, but like the idea is that you can put it through there, it produces something that's consistent. And then what's nice about that is the reason why hashes are really important is that it's hard to go backwards. Essentially, it's hard to undo a hash. This is actually, if you guys are familiar like with Bitcoin or cryptocurrency, that's essentially their premise, is that it's really easy to go one way, but not the other way. So these are called one-way functions. So when we say a hash table, basically it means it takes information, basically encodes it into some information that is like, if you put the same document or same data through, it will produce the same output. And that way you don't have to actually look at it specifically. This is a good lookup table, because then instead of having like, let's say you have like I'm making some stuff up. Let's say you have like a 5 GB data file. You can put it through a hash and you'll get the output through here. But you don't have to keep the whole 5 GB data file. And if there's like one word that's different, well, in order to know that one word, if you have the whole data file, we have to compare that whole data file with this other data file, which has only one word different, and take a long time. What a hash does is that if it's slightly different, it should produce a different hash. Not a slightly different hash, but a different hash. And what's nice is that you can compare those two, say, oh, these are not the same. Okay, that means these documents are not the same, without ever looking at the actual document. So that's why it's really useful to do that way. And that's what we mean by a key value store. So that key would be, in fact, the hash. Okay, and the value would be whatever you put the data. Cool. Understand it for that one? Okay. So last one, graph databases, which I will be honest, I don't have as much experience with it. But basically is that when you're using a graph database, essentially what you're doing is you don't necessarily, how do I say this? The important aspects are the relationships themselves. So it's not necessarily the data itself, like, which is important, but it's actually the relationships between the two. So you can think things like, you know, like social networks, fraud detection. So you can imagine if what kind of things someone does, like what kind of relationships they have with other, you know, parts might send red flags for fraud, you know, and stuff like, oh, they're doing these certain actions, or they're talking to this certain, like these certain businesses, which we don't usually see. Those are the kind of relationships that are important. You can also think like knowledge graph, recommendation engines. So you can imagine like the relationships of like what movies you watch, you know, kind of thing might be important versus, yeah, I won't go into full, I won't go into full detail about this, but like you can think of like, you know, like how a person looks at different movies and seeing how those, what movies they watch, and then compare the similar graph to someone who's like, well, they have similar relationships with those movies. So those might be also similar pathways. So you can basically, the important part is that these graph databases are focused on the actual relationships versus just the data itself. Okay, cool. All right, and so those are all the different data model types that we'll kind of talk about. I think that's everything that the curriculum mentions, but we'll really focus on today document stores for MongoDB. So just kind of know that's what we're going through. There are plenty of others like I said, mentioned, like Cassandra, what's the other one I was thinking of? Big table from Google and stuff like that, and Amazon Redshift, and there's a bunch of other NoSQL parts. So if you're curious, definitely take that time to kind of research a little bit and just play around with it. But don't feel that you have to know these things, because quite honest, like no one knows all of these things. And if you did know a lot of these things really well, you probably be closer to the data engineering side than you are a data scientist. But as a data scientist, we have to wear many hats. So sometimes we have to know some of this data engineering and what's the advantage between the two. Okay, cool. So any questions on these different model types? All right, sound cool. All right, so the last part I just want to talk about is just this fault tolerance and then resilient distributed databases, or you'll hear more commonly called RDDs, right? So basically the idea is that if something fails, like if I have just one server and that one server messes up or something happens to that server, there's a leak, like, and it shorts or whatever, you want to make sure there's a backup, or basically be able to do this. So basically, this is what we call fault tolerance. Basically, how much can you like mess up before essentially everything's gone? So there's some ways you can do this. Resilient distributed databases or data sets are basically, the idea is that you can have redundant copies on multiple servers and stuff like this. So if one server were to go down, you have backup. So, you know, like little copy and paste here, right? So I say, like, use this phrase, 2 is 1, 1 is none. I think it's a really important thing, like just in life. But that's essentially what we're doing when we do talk about RDDs. Now, what's kind of interesting, I'll kind of, before I go into this part, is that there are a lot of big companies that have to consider this kind of thing. One big example is like Google. Google has a lot of data, a lot of information, right? So what's kind of interesting is that I think it was Randall Monroe, who does the XKCD comics. He basically made a calculation of like, you know, how much data does, you know, Google actually have? Because they don't publicly really release how much information they have and like what they, you know, like where it's stored and everything like that. But he did kind of figure is that if you're putting it on these disk drives, like hard drives and stuff like that, or whatever drives you have, they have a failure rate randomly, right? Sometimes they'll just break. And they have so much data that I think it ended up being like less than every few minutes, a disk would break and they'd have to actually replace that thing. So if they basically have so much data and the probability of one drive just breaking is, you know, not zero. So they actually have to think about, you know, how often do the drives actually break and making sure they have redundancies. So that's the kind of level when you're talking about big data and stuff like that, and making sure that you have enough information. So one solution basically is to keep redundant copies. Now, one solution to this is literally just keep like a backup. Like you have one server and then each server has the exact same information. What's the problem with that? Especially when you consider large amounts of data.
You're going to run all your queries on this huge data just through one of those servers. and the others are just sitting there waiting for that first one to break, it seems like it could be more efficient.
Yeah, it's probably not the most efficient, especially if a lot of data, right? And imagine if it's like, you're trying to keep everything on one server, you can also have a very large server, and then you also have a large backup, and it's kind of like, oh, this is no good. So there's some other ways you can do this. So I'm going to point to this like free course on Hadoop. I'll let you know Hadoop is, we'll talk about this in the future, like probably like section 38-ish. So we're going to take a while to actually reach this again, but I thought I'd mention it. Hadoop is definitely a little more older school. It runs on Java and stuff like that. It's a little bit slower, but there's still plenty of industries that still use Hadoop, and they're still important to understand. For example, Facebook actually uses Hadoop. They did not transfer over to anything faster. A similar one is Spark, which we will talk about for sure and use in like section like 40 or something like that. And so those are kind of the news parts. Spark is kind of relatively new. It's kind of taken up a lot on the data science space. It's because it's faster. But anyway, the main thing about here, and this, I got this little screen grab right here from this course, is you can see, like, you can imagine each of these blocks of servers. And each of these like different green, red, blue, like all these different like little markings are essentially different sets of data. So you can imagine is that this one has a red and green set of data, that maybe you have red and blue over here. So you basically chunk out your data and basically split it across multiple servers. So that way, no one server probably has all the data, but they have parts of each other data. Basically, they stripe it across. So this makes it a little more efficient. Now, how exactly you would do this? Usually you don't do it yourself. You would use something like Hadoop's, like, some kind of manager, basically to deal with where the data should go and everything like that. Okay. So anyway, I was pointing to you guys this part. I'm going to mention real quickly, I'm not going to dread on this too much, MapReduce, because we'll talk about this again in the future when we talk about some, using this. But MapReduce basically allows us to approach this in a distributed way, in a parallel. Well, could be parallel, but mostly distributed, is that you can have data in multiple parts and then combine this information together to actually perform functions on it. So right now, we're going to mostly focus on like a local one computer doing stuff. But in the future, when you have big data, you might have it multiple parts, and MapReduce basically allows you to essentially take information from multiple servers, which might all have slightly different information, map it out, and then later on combine it together so you can actually do stuff with it. So again, we'll talk about this in the future. Any quick questions? I know this is very general, very like nothing specific, but any questions on this resilient database or distributed data sets? Okay. Cool. All right. So that kind of ends my intro to NoSQL. And we'll go into now MongoDB. So MongoDB is kind of what we should talk about in the curriculum. One focus. I'm going to go ahead and do a kernel restart and clear this out. Okay. So you can see we have a few things on here. So basically for MongoDB, and I'm going to bring this up right here, make a new thing. First thing to make sure, since we're doing it from the curriculum, make sure you actually are on that virtual environment, environment. So I'll do this real quick. You can see I'm on base right now. It's learn-env, right? It's good. So make sure you have it on there since you installed it on that part. And then I just do Mongodb, which I think is hilarious. But anyway, Mongodb, which will actually run MongoDB, and you can see it probably already have it running. So that's why it's probably saying. So, what was I at? I can't remember what.
Trying to see if you already have a Mongo instance running.
Oh yeah, I think I do actually. So I realized because I closed some terminals and I didn't stop it. So let's see if this will run by itself. So I started MongoDB. So if it is running, this will work. If not, then no fail. Oh, I did point to one of the other instructors, Raphael. You guys haven't met Raphael yet, have you? No, okay. He does a lesson on here, so note that I kind of borrowed some of this stuff from here, but he also has a, I think, recording and also on the student resources as well as like the actual lesson. So if you wanted to see some more, you can check this out too. So always most useful. Note that I was showing you could run this in here. If you do this, it won't work because, or you can't do anything else because the problem is that this is going to run in here and MongoDB is going to run in the background and you can't do anything. So basically you have to start here and you can never run this part. So that's why I'm just showing you guys. But it connects to this default local host right here. So you'll notice that this right here, 127.0.0.1, that means localhost. You can think of like home or whatever, like that's essentially what's going on here. So if this runs, okay, so no module. No module. What am I?
That's
Oh,
what I kept getting.
I'm on the wrong environment. Okay, let me go ahead and get that going properly. So let's see here. So this is one of the things that you have to make sure you're in the right environment. So I think I started this up without that environment in there. So let me do a source, activate. Oh wait, I can just go here. There we go. So you can, it'll probably say base here. Yeah, you can see base. So I'm going to do source activate learn.environment. Okay, and now I can do Jupyter Notebook, and that will run through. Okay, cool. And now this should be up now. MongoDB. Let's just do a refresh.
So Victor, was it maybe not working for me because I was like going through the coding on the Learn site?
Oh, we're using learn.co?
I was like just for the lesson. Yeah.
That might be why. That might be why.
Okay.
So we can check definitely Learn when we have our Learn one. Definitely let me know. Okay, so let's try running this now. Okay, good. So imported through here, and then this should fail if there's no MongoDB running or Mongodb running. Otherwise, this should be fine. Cool. So there's Mongodb still running. So that's why I had that failure up here, and you can see from this part right here, like you guys had mentioned, there's another instance running, which is why this shut down. Basically, you can only have one at a time. You can see that lock. So cool. All right. So I have basically connected to this client, PyMongo. So note that PyMongo is just a way to interact with MongoDB. And there's other ones on here, but this is the one that we talked about in the curriculum. The Mongo client built into PyMongo. The localhost, remember that's that 127.0.0.0, right? So that's kind of the equivalent. You could have also done this right here. But I'm just kind of showing you some alternative ways. Okay, so now we can actually see, okay, now that we have the client list, let's check out what's in the database. So you'll see there's some extra stuff depending on what, if you've run this before, you might see this parts. For example, you can see here's an actual part that I had run before. So just know that you might have some databases if you had it previously. So I'm just going to kind of show you how you can create like some new databases. So you can see I already ran this before. That's why this attendance is still here. But if I didn't, I can basically say, okay, my DB, which is basically my database, is equal to client. So remember that client's up here. And I'm going to say, okay, make this database. If this database didn't already exist, it would create a new one. Okay. But in this case, it does actually exist. So we can actually see listed database names like I showed before. And if I didn't have a new one here, let's try something new. Let's call it a different database. Let's say new attendance. Again, I'm super creative. So you should now see new attendance down here. Oh, wait, because we haven't done anything yet. We haven't actually attached anything on it. So there's nothing in there, but you can see the idea here. So I'm actually going to keep attendance just in case something weird happens. Okay, but same process. Okay. And we can also see the collection names. So you can see here, attendance is basically things that actually have a collection in there, right? So we created our database. That's kind of the process. These really, this is the only process you need to create the database. This was more like just looking at different parts of it. Now we are going to do create, read, update, delete, which is also known as CRUD or CRUD, right? And basically note that, you know, CRUD basically are different, it's kind of like a philosophy, it's like what things you can do. It's not specific to MongoDB, it's not specific to SQL, it's not specific to NoSQL. It's more like an idea. It's like, well, you can create records, you can read them, you can update, and you can delete. Okay, so it's a good kind of thing to go through. So first, let's actually create some records, right? So assuming that there's nothing in this database kind of deal, I can say, okay, let's go ahead. Students are going to connect to my database right here, okay, of attendance. I run this guy, and now I have my keys. So I'm going to say in my thing, this information I want to keep. I want to keep their name, their age, and then what state they're in. So you can imagine this is going to be, I think in this case, it's a scenario of different students, right? I have a bunch of different students. So in this case, I'm going to say Victor, right? The name is Victor, age is 28, California is their state, okay? And you can see here, this is just a dictionary, very simple. Note that there's an alternative way I could have done it this way. So this is kind of a fancy way, but this is probably what you'd be most familiar with. So I run this, and you can see I have Victor perfectly fine. And now I can actually insert this, students.insert one Victor. So this is going to insert one record into my certain, what's it called, my record, okay? So I'm sorry, not my record, my collection. So I can do this part, and you can see here this gives us just results. So you could actually take this result, see if it's successful or not, but I'll assume successful going forward. So that's how we insert one record. Now, if we want to insert many records, so imagine if you have a huge database, a data frame, for example, you might insert many different ones, right? So for example, I have anti-Victor here, which is -27, new student, max, state is Oregon, right? Age 25. And you can see records. I can say, okay, these are all my records. So this is a list of dictionaries, right? Okay, and so you can see my records. So if I actually split this up real quick, you can see there's my records, and then I can insert many into those with those records, run that, and now you can actually see my records, and you can see I actually have all our parts, right? So, oh wait, sorry, I don't know why I did this again. Yeah, I don't need this. That's the same thing as this thing right here, if you remember. Okay, so now we can actually test it out. Say, okay, well, sure, I inserted them, but let's actually see what's going on here. So one thing to kind of show is that we can accidentally overwrite parts. So let's see here. If I do example equals this guy, and I insert this one example. Oh, I have to run this first. There we go. I inserted this. Note that this is the inserted ID. So that's what's going here. But it actually changed my example here. So that's why I printed it out before. Sorry, past Victor didn't explain that very well. Is that this example here was my dictionary, right? Which I had defined. But if I try recalling this dictionary, note that this gets changed, that it does actually add on to this part. So just kind of be aware that this is when you're passing this example, it's not passing in just like this thing and then like, it keeps it the same. You're actually passing in to modify it, and this will actually modify this part. So just kind of be aware of this aspect. Okay, but that is how you would insert records or, one record. Okay, any questions? Sound pretty straightforward. Just remember that it has to be a dictionary, basically that key and that value. Okay, cool. So then we can actually read these parts. So right here I have this list comprehension, P for P in students.find. So note that students, again, is my collection, and I can do .find, basically find everything. So when you do a .find, we'll show other ways to specify like what we want. But if you do just .find, this will just do everything. This is everything. It's like basically everything's attached to a blank. So you can see here I have Victor, I have anti-Victor, right, which is just name Victor, Max, and then John. Okay, so again, just different people in there. And then I can do specifying output. Okay, so let's say, for example, it's like, well, okay, I found all the students here, right? And I got all this information, but I don't want the object ID. That's just junk I don't need, right? So I just want the name and the age. So this is basically specifying I want the name. One meaning like, yes, I want name. Age, yes, I want age. Okay, so if I do this now, this will actually print out all the students. So Victor, anti-Victor, which is Victor, Max, and John. And those should only print out the name and the age. So you can see here, if I do this, you can just see, have the name and the actual age. Note that there is this part right here, is the actual object ID. Okay, this is always going to be passed through every single time. And note that that little beginning, underscore ID, that underscore is supposed to basically say, oh, this is a private variable that you really shouldn't worry about, but it's going to get passed through. Okay, so that's how we specify what properties we want. We can also say, I don't want certain ones. So, okay, list everything, but I don't care about the name. I don't care about the age. So we'll do something very similar. And this results, you can see it just shows out the state. So if there's something like a specific column, like, oh, I don't want these parts, or I want these parts, you can use either 0 or 1. Okay. Any questions on how to, and this is just specifying output.
Can you have like name 1 and age 0?
Let's try it. Let's try name 1 here.
Yeah, okay, that's what I thought.
Yeah, so the way it's structured, it looks like you really can't do that, right? So this is the nice thing is that, I like to say, like, if you come across something, try it out, right? And see if it works. And then the next step would be like to search, like, well, maybe there is a way. And then people usually pretty quickly on Stack Overflow will say, yes, no, or like, that's a really dumb thing. So just kind of be aware, like, not that saying that was a dumb thing or anything, but like, you come across these answers at times. Anyway, that is how you would specify and not specify. Okay, cool. So, and this hopefully that kind of makes sense too, why we can't do just 1 and 0, because it's basically the same thing. Like if you say don't include this, but then you say include this, it's kind of confused. Like, well, which one should it care about? Should it only show name and nothing else? Or should it not show age and nothing else? So that's kind of why I think it is a failure. Cool. So we saw here, if you pay attention closely, you saw that there's a first parameter that's passed an empty dictionary, right? That's what this is. That's because I just want everything, right? But if I want a specific record in here, I can actually specify what record I want based on what. So in this case, I want everyone that has the name Victor, which we know are actually two records, Victor and anti-Victor, right? So you can see here, there are two separate records. Okay, cool. So these are kind of like what you can define. There are some other modifiers. So for example, you can say age is greater than 26. So note that before we have to do like name and then like the value, we can actually use these modifiers right here, which are also dictionaries. Note that this is very similar to JSON format. That's because MongoDB, besides Python, can actually take in JSON format. So it kind of has something similar here, but that's what is greater than here. And these are just modifiers. So note that is a special way of specifying this. And this will find everyone who is greater than 26, which I believe should be 2 people, right? So John and Victor, okay? So just know that there is some reference here. If you wanted to find, well, what do less than? What other modifiers can I do? There's a whole example here. For example, equal to, greater than, equal to, in, not in, and there's a whole bunch of things like using and ors and stuff. So some things to kind of check out and stuff like that if you want to specifically look at stuff. Okay, cool. Any questions on specifying output, or not specifying output, searching records on how you would do this? Pretty cool. Okay, awesome. So let's go to the next part of CRUD, which is update. So updates, like we already got the records in there. We'll say we're going to update because, like, you know, oh, the person's age actually changed. Let's say they have a new birthday, right? So you can see here we have a modifier set, and that's going to say set and then what the actual values are right here. Okay, so you can see here, this is the record that I actually want to update. Here my update 1, update 2. Note that I kind of try to keep it separated. That way it's a little bit easier for us to like read down here. Okay, so you can see here, I'm going to update 1 record, or update 1 record to update, the actual update I'm going to do, and then do it again. And then I can double check. So if I do this part, let's see this. This should go through. You can see I actually got results. And then I can check, confirm this, and I can run this. And we can see that Victor actually, and just that Victor right here was updated. Okay, cool. All right, and the reason why it's only updating 1 record is because I said update 1 versus update all or something. Okay, any questions on this? Cool, sound good? All right, and then our last part is delete. So like this is important because we want to get rid of some like information, right? So we can actually delete 1 record right here, and you can see if I do this, you can see I deleted 1. And just know that 1 is just basically saying how many I deleted, right? That deletion.delete count. Okay. So let's see here. Our next one, we can actually delete, you know, other parts. So you can see here, we can delete ones that are less than 27 years old. So note that should include, I think, won't include John, but it'll include Max and Victor, who I call anti-Victor, right? Or I guess, no, yeah, because anti-Victor already got deleted. Well, let's double check, right? So let's just double check our results. So let's say, let me ask you guys, how would we print out, check the database right now? If I want to see what's in the database, or yeah, what's in the database in this collection right now. Should I scroll up a little bit for you guys to see?
You could do a .find and then curly braces with nothing in the middle.
Yeah, right. So you can do students .find, right? And oops, .find. You could put a curly brace right here, or you could just leave it empty. That works either way. And then I showed you guys results, but I could just do like for R in this guy, and then just print R. And you can see here, that's everything that's in my database right now. Okay. So, okay, cool. So that means we should get rid of anti-Victor and Max, right? So all that should be left after that is John. So I run this now, delete those parts. Oh, I only deleted 1, right? So note that it will delete the first one. So it just should delete anti-Victor. You can see there's Max right here. So if I delete another one, you can delete it. You can delete the next one, right? So if I do this again, it would delete this one. Okay. Note that I can also delete many. So if I delete many, note that they're basically, in this case, this is saying delete many with no parameters. This will delete your whole database. So if I run this now, you will see that I actually have no records anymore. Okay. So this is essentially how you could do this, but you could also do delete many, have a specific part. So if I ran this first with delete many instead of delete 1, this would delete everyone who is less than 27 years old. Okay. Cool. Any questions on how we would delete these things or specifying? No? Okay, cool. All right, just be careful because it does, you can see there's no confirmation. It just goes right through it. Always be aware of that when you're doing any kind of deletion or updating even. Okay, cool. So I think.
Can I ask one quick question?
Yeah, go ahead.
Okay, so for these ones where you're finding one or you're updating one, or you're deleting one, you know, it's searching and it's finding stuff and then it's doing it just to the first relevant result. Will it always find things in the same order? Like, can I trust that it'll be the same order?
It'll go off of the object ID, which
okay.
the object ID should be increasing sequentially as you add them in. So there's still an order in place, but that order is based off of this object ID. So that's why this is always inserted first. That makes sense?
So I would need to know, you know, say I want to find all the Victors and delete the first one. I would need to know that that first one is the first one that I added and that's the one I want. Or I'd need to set up some more sophisticated search to make sure it's Victor A, not Victor B.
Yeah, and that's where, to be quite honest, I don't like saying delete like one and then saying, oh, it's just going to delete the first one. I think it's a good idea to actually specify as much as you can what are the things that are relevant to delete, you know, kind of deal. At least delete one will make it a little safer instead of like delete many and then you find out you deleted all of these things because you accidentally messed up that query. In reality, you probably would want to do something like find one or find right here first before you delete it. That's always a good thing to do. Just not just MongoDB, but anything you're going to delete because that's important. I would also say the same thing with update. Update, a lot of times for a lot of systems, update is the same thing as delete. Essentially, it's deleting and then inserting. In a lot of ways. Like if this makes sense, like if you update, but you didn't mean to take off this birthday, now you also overwrote that birthday, now you can't get it back. So update sounds less scary, but it can also do the same stuff where you basically overwrite something where maybe, for example, you put this on here and you put an empty string by accident, and now you overwrote everyone's birthday. You're like, oh, shoot, that's not good. So just kind of be aware of those things too. Cool. All right. And then this last part, I'm just going to point you over to like MongoDB's manual. You can actually run stuff directly. So we saw Mongodb and like people run here. You can actually run these same queries and stuff like this in the Mongo shell itself. So just kind of know, let's see if I can see an example real quick on the bottom here. So you can actually run these things directly in the terminal. So that's why, for example, but what's nice is that because we're using Python and JSON kind of similarity, you can see it's actually not too difficult to kind of see that similar part. So this is not Python, this is actually using the interface directly from MongoDB. So just know that's an option as well. Okay, cool. All right. So with that, that's kind of like all I had to show for this section. You guys have any questions or anything else about MongoDB, NoSQL? All right, cool. So I guess I'll go ahead and stop it here.